If you've ever searched online for a quick way to clean an oxygen sensor, you've probably seen dozens of shortcuts. Soaking it in fuel, blasting it with sprays, brushing off the tip, or even dunking it in chemicals people swear will bring it back to life. And on the surface, these tricks sound harmless. It's a small sensor, it looks simple, and replacing it isn't exactly cheap. So why not try to revive it? But here's the truth. Most drivers don't hear until it's too late. Almost every popular oxygen sensor cleaning trick does more harm than good. Not only can these methods destroy a perfectly functional sensor in minutes, but they can also send your engine into a downward spiral, wasting fuel, damaging your catalytic converter, and costing you far more than a replacement ever would. Modern engines depend on this tiny part more than most people realize. Every second your car is running, the oxygen sensor is feeding the computer the information it needs to balance fuel and air. When that sensor goes bad, the whole system gets confused, and your car pays the price. So today on Mechanical Wonders, we're cutting through the noise. I'm going to break down the biggest mistakes drivers make when trying to clean an oxygen sensor, explain exactly why these hacks destroy the part, and share the real-world experience that seasoned mechanics already know. Some components should never be cleaned. They should be respected or replaced. Let's start with the worst one of all, the one that so many drivers try because it looks simple, cheap, and harmless, yet it destroys sensors every single day. Part 1. The dangerous myth of soaking an oxygen sensor in fuel. One of the most common DIY cleaning tricks you'll see online is soaking the oxygen sensor in gasoline. Some people even go a step further and heat the fuel to strengthen the cleaning effect. And the logic sounds convincing. Fuel dissolves carbon, so why not use it to clean off the soot? But here's what those tutorials never tell you. Soaking a sensor in fuel is the fastest way to kill it permanently. An oxygen sensor isn't just a piece of metal that gets dirty. It's a precision device coated with ceramic and ultra-thin layers of platinum. Materials engineered to detect oxygen levels with incredible accuracy. The moment gasoline touches that delicate surface, it starts breaking down the protective coatings. And the moment fuel seeps into the tiny ceramic pores inside, the sensor is contaminated forever. Once those coatings dissolve, the sensor no longer knows how much oxygen is in the exhaust. Your engine begins running blind, adding too much fuel, choking itself with richness, dropping mileage, misfiring, and triggering the check engine light in the process. Many drivers notice rough idling or sluggish acceleration immediately after trying this so-called hack. Others find that the sensor kind of works, but only for a few days before it becomes slow, unresponsive, and eventually fails completely. And here's the part most people overlook. There is no chemical, no soak, and no magic liquid that can reverse fuel contamination inside an oxygen sensor. If gasoline has already made its way into the ceramic core, the sensor is done. A quick wipe for dry soot is acceptable, but if the tip looks glazed, oily, or melted, don't waste time or money. Replace it, and before you do, always confirm with a scanner or multimeter to make sure the failure is real and not caused by another underlying problem. Part 2. The hidden damage caused by spraying brake cleaner and other aerosols now. If soaking the sensor in fuel is the classic mistake, spraying it with brake cleaner or carb cleaner is the one that catches the most people off guard. It feels logical. It feels fast. You see grime. You see soot. You reach for the strongest cleaner you have, because that's what usually works on engine parts. But oxygen sensors are not ordinary engine parts, and aerosol cleaners are far more destructive here than most drivers realize. Brake cleaner and carb cleaner are engineered to break down oil, grease, adhesives, varnish, basically anything tough enough to cling to metal. Unfortunately, these cleaners don't know the difference between heavy grime and the microscopic platinum coating on an oxygen sensor. The moment these chemicals touch the sensing tip, they begin stripping away that ultra-thin layer, eating directly into the ceramic that lies beneath. Even worse is the residue they leave behind, The can may say quick drying or zero residue, but the truth is microscopic traces of the solvent remain trapped within the sensor's tiny pores. To the human eye, it looks clean. To the engine computer, it looks like chaos. The sensor begins reacting at the wrong speed, detecting the wrong oxygen levels, or sending unstable voltages that confuse the ECU. You end up with misfires, poor acceleration, failed emissions tests, and fuel economy that suddenly drops for no obvious reason. Car manufacturers themselves warn against this. Bosch, Denso, NTK. They all say that spraying aerosol cleaners anywhere near the sensing element is a guaranteed path to early failure. They see these sensors returned under warranty all the time, and almost every damaged one shows the same signs: chemical corrosion, coating loss, and internal contamination caused by cleaners. If you notice light gray soot on the outer metal shield, wiping it gently with a dry cloth is acceptable. But the tip itself, the heart of the sensor, should never be exposed to aggressive solvents. If it's oily, sticky, or darkened, that is no longer a cleaning issue. That is contamination from fuel, oil, or coolant, and contamination cannot be washed away. In short, these cleaners don't bring a sensor back to life. They simply ensure that whatever life it had left is gone. Part 3. The silent internal damage from high-pressure air blasts. Just when you think drivers can't find new ways to harm these sensors, there's one more trick that looks harmless but causes damage you can't see or fix. That trick is blasting the sensor with compressed air. It sounds innocent. It's just air. No chemicals, no solvents, no liquid. People use compressed air on almost everything else in the engine bay. So why not here? Because inside, every oxygen sensor are incredibly small air passages that allow fresh air to enter the sensor for reference. These tiny channels let the sensor compare outside oxygen with exhaust oxygen, which is how it calculates the air-fuel ratio. When you hit the sensor with high-pressure air, you force dust, moisture, and microscopic debris deep into those critical pathways. The moment those channels become contaminated, the sensor begins losing accuracy. At first, you might see nothing wrong. The engine idles fine, the acceleration feels normal, and everything looks okay on the dashboard. But internally, the reference air system, the most delicate part of the sensor, is already compromised. And once that system is blocked or contaminated, the failure is irreversible. Manufacturers like Bosch have stressed this repeatedly in technical bulletins. Forcing air through the sensor destroys its ability to measure oxygen correctly. Even a brief burst can ruin the internal structure. And what makes this especially dangerous is that symptoms often show up days or weeks later. The driver has no idea that the cleaning they did last month is the reason the sensor is now sluggish, or the ECU is compensating with the wrong fuel mix. If a sensor is damp from washing the area around it, let it air dry naturally. If it's dusty, wipe the metal housing gently. But never under any circumstance blow air directly into it. High pressure may remove a little dirt quickly, but it will cost you accuracy, fuel, and eventually the sensor itself. Just like with chemicals, this is another case where a shortcut ends up costing more than a replacement ever would. Part 4. The costly mistake of scrubbing or using wire brushes. If there is one mistake that feels the most tempting and the most destructive, it's scrubbing an oxygen sensor. Many drivers look at the dark soot around the sensor tip and assume it works like any other metal part. If it's dirty, scrub it. If it's stubborn, brush harder. That logic works on battery terminals, rusty bolts, or brake calipers. But the oxygen sensor is a completely different world. The tip of the sensor is coated with a layer of platinum so thin it's practically invisible. This coating is what actually reacts to changing oxygen levels in the exhaust. Without it, the sensor becomes nothing more than a dead piece of ceramic. The moment a wire brush touches that tip, even lightly, the platinum layer is scratched, thinned, or completely stripped away. This damage doesn't show up like a broken part. You won't see cracks or chips. What happens instead is quiet and gradual. The sensor's response becomes slower, the readings become inconsistent, and the engine computer begins overcorrecting the mixture because it no longer trusts the signals it's receiving. Suddenly, you get warnings, misfires, poor mileage, and rough running that seem to appear out of nowhere. But the real damage happened the moment the brush touched the sensor. Manufacturers compare the sensitivity of the sensor tip to a microscope lens. Even the natural oils on your fingertips can alter how it reacts. Sanding it or brushing it is the equivalent of dragging sandpaper across a camera lens. You might remove the dirt, but you destroy the thing that makes it useful. For the outer metal housing, a soft microfiber cloth is the limit. Nothing abrasive, nothing harsh, and absolutely no attempt to restore the sensing element. Once the platinum coating is damaged, there is no way to rebuild it. The only solution is replacement. Trying to bring back a damaged sensor by cleaning it is like trying to sharpen a cracked spark plug. You're fighting against the design of the part itself. Scrubbing is not maintenance. Scrubbing is a guaranteed way to shorten the life of your sensor and increase your fuel bills without realizing why. Part 5. The hidden danger of WD-40, silicone sprays, and oil-based products. Another mistake that destroys oxygen sensors happens even when drivers never touch the sensor directly. It occurs when someone sprays WD-40, silicone lubricant, or penetrating oil near the area, thinking they're just loosening a bolt, sealing a gasket, or lubricating a connector. What they don't realize is that these products release vapors, and those vapors drift everywhere, especially in the engine bay where heat constantly rises. Oxygen sensors are incredibly sensitive to oil and silicone contamination. When vapors settle on the sensing element, they create a thin, invisible film that smothers the ceramic surface. This condition is called sensor poisoning, and it slowly prevents the sensor from reacting properly to oxygen changes in the exhaust. At first, the engine computer tries to compensate. It may enrich the mixture slightly, then lean it out, then adjust again. Over time, the readings become unreliable, and the EQ finally has no choice but to trigger a check engine light. But the damage doesn't stop at the sensor. Those same silicone and oil vapors can travel downstream into the catalytic converter. Once they deposit on the converter's surface, they block the chemical reactions needed to clean exhaust gases. This can lead to poor emissions, overheating, and even total catalytic converter failure, a repair that can cost 10 to 20 times more than a new oxygen sensor. For this reason, manufacturers are very clear. No oil-based or silicone sprays should be used anywhere near the sensing tip, the vent ports, or the electrical connector. If anti-seize compound is required on the threads, only a tiny amount should be applied, and only to the threads, not the body of the sensor. Many modern sensors already come pre-coated from the factory, which means adding more product is not only unnecessary but risky. Connectors should also remain completely clean and dry. Adding grease or dielectric compound inside the connector may feel like good preventive maintenance, but for oxygen sensors, it's a direct path to contamination. A few careless sprays can turn a healthy engine system into one with poor mileage, rough idling, and expensive emissions failures. And in almost every case, the driver has no idea their maintenance trick was the cause. Part 6. The expensive consequences of incorrect reinstallation. Even if you never soak, spray, scrub, or blast the sensor, there's another mistake that ruins more perfectly good oxygen sensors than people realize. Improper reinstallation. It sounds simple. Unscrew the old one, screw in the new one, clear the code, and drive. But in reality, installing an oxygen sensor incorrectly can cut its lifespan in half or destroy it immediately. One of the most common issues comes from using too much anti-seize compound. Drivers often coat the threads heavily, thinking it will make removal easier next time. What they don't know is that excess anti-seize can migrate up the threads as the sensor heats up, creeping toward the sensing tip and causing contamination. Even worse, most modern oxygen sensors already come with a factory-applied, ceramic-based anti-seize coating. Adding more not only serves no purpose, it actively adds risk. Another installation mistake is over-tightening. The housing of the oxygen sensor is designed to seal by itself. When you torque it down past the recommended value, the stress can fracture the internal ceramic element. This damage won't always be visible. The sensor may appear normal, yet after a few heat cycles, cracks expand, and the sensor becomes slow, inconsistent, or completely unresponsive. Incorrect wire routing is another silent killer. When the wiring harness is allowed to touch hot exhaust components, the insulation gradually melts or becomes brittle. As soon as the wires short or the protective sheath opens, the heater circuit fails and the sensor becomes lazy. The driver blames the sensor itself, not realizing the real issue was a simple installation oversight. And then there's the problem with universal sensors. They often require splicing and connecting wires manually, a process that demands precise matching of resistance, wire gauge, and heater specifications. Even a slight mismatch can cause the ECU to interpret the signals incorrectly. Many drivers think they saved money by choosing a universal sensor, only to find the check engine light returning week after week. To avoid all this, proper installation must be done carefully and deliberately. Disconnect the battery before starting so the ECU resets cleanly. Use a torque wrench, not guesswork. Route the wires neatly and far from heat. And always clear the old fault codes before driving, so the computer can relearn from a clean baseline. A well-installed sensor lasts years. A poorly installed one fails in months, and the engine performance suffers long before the driver realizes what went wrong. Part 7. Why trying to revive an old sensor rarely works. This brings us to the most common mistake of all: trying to clean or revive a sensor that has simply reached the end of its life. Many drivers cling to the idea that oxygen sensors only fail because they're dirty on the outside. But the truth is far more complex. An oxygen sensor doesn't usually fail because carbon builds up on the metal shield. It fails internally. After tens of thousands of ignition cycles, years of extreme heat, and constant exposure to exhaust gases, the ceramic element inside slowly loses responsiveness. The heater element weakens. The voltage swings become slower, and eventually, the sensor simply cannot keep up with the rapid changes in the exhaust stream. No spray, soak, scrub, or cleaning trick will restore a worn-out sensor's internal function. You cannot reverse ceramic aging. You cannot recoat platinum at home. And you cannot make an old heater element behave like a new one just by wiping the housing. Worse still, a sluggish oxygen sensor often doesn't feel catastrophic. The engine still runs, so drivers assume everything is fine. But the damage happens in subtle ways. The ECU begins adding too much fuel, the catalytic converter runs hotter than normal, and fuel economy quietly drops week after week. Over time, this hidden imbalance can shorten the life of the catalytic converter, a repair that can cost thousands. If your OBD2 scanner shows slow switching data, flat voltage curves, or delayed response times, the sensor is nearing the end of its life. If your mileage has dropped and your exhaust smells richer than usual, that's another sign. And if your sensor has over 60,000 to 100,000 miles on it, replacing it is usually the smartest move, even if it hasn't failed yet. Seasoned mechanics know that changing a tired oxygen sensor often brings instant improvements: smoother idle, stronger acceleration, cleaner emissions, and noticeably better fuel economy. You are not just replacing a part. You are restoring the accuracy of the entire combustion system. Aging oxygen sensors cannot be restored. They can only be replaced. And replacing them at the right time isn't a cost. It's an investment in fuel savings, long-term engine health, and the performance your car should have had all along. Bonus tip: the one hidden issue most drivers never check. The heater circuit, even after replacing the sensor, even after installing it correctly, and even after avoiding every cleaning mistake we've talked about, there is still one overlooked detail that silently affects performance: the heater circuit. Most drivers don't realize this, but every modern oxygen sensor uses an internal heater to reach operating temperature quickly. Until it warms up, it cannot read oxygen accurately. And if that heater is weak, failing, or has the wrong resistance, the sensor wakes up too slowly, sometimes taking minutes instead of seconds. During that delay, the EQ receives incorrect data. The engine runs richer than it should. Fuel gets wasted, cold start emissions increase. And because the readings look almost normal, many drivers never suspect the heater. They blame the sensor, the fuel, the spark plugs, or even the catalytic converter. When in reality, the problem is simply that the heater circuit is aging. Testing it is simple. A multimeter can measure resistance across the heater terminals. Your vehicle manual provides the correct range. If the resistance is too high or too low, the heater is weak, and the sensor is no longer capable of waking up on time, even if the sensing tip still looks spotless. Replacing a sensor with a lazy heater can immediately improve cold start behavior, reduce fuel waste, and restore proper air-fuel balance during warm-up. Many professional mechanics always check the heater circuit before declaring a sensor good or bad. It's a diagnostic step that separates quick parts changers from true engine technicians. A functioning heater isn't just an accessory inside the sensor. It's a critical system that keeps the combustion process stable in the first few minutes of every drive. Sometimes the most expensive problems come from the simplest parts being overlooked. Conclusion: treat the sensor right, and your engine will reward you at the end of the day. Oxygen sensors are not heavy-duty engine components you can scrub, spray, blast, or revive. They are precision instruments, engineered to operate within microscopic tolerances and survive in one of the harshest environments in your vehicle, the exhaust stream. Their entire purpose is to react quickly and accurately to oxygen changes, and that level of precision does not mix well with cleaning chemicals, brushes, compressed air, quick fixes, or DIY hacks. Whenever drivers attempt these shortcuts, the result is almost always the same. Instead of restoring the sensor, they damage it. Instead of saving money, they end up replacing both the sensor and other components downstream. Instead of improving performance, they unknowingly cause the engine to run inefficiently for weeks or months before the symptoms become obvious. But when you respect the design of the oxygen sensor, when you avoid harmful cleaning methods, install it properly, and replace it at the right time, your engine rewards you. You get smoother idling, cleaner emissions, sharper throttle response, and real fuel savings that add up every time you drive. Modern engines depend on accurate information. With bad data, even the most advanced EQ cannot balance the combustion process correctly. But with a healthy oxygen sensor delivering clean, precise signals, your engine becomes more efficient, more responsive, and more reliable. So treat this small but powerful component with care. Don't fall for shortcuts that seem clever but cost you in the long run. When in doubt, avoid cleaning and choose replacement instead. Your engine will thank you every time you start it. Your catalytic converter will last longer, and your fuel money will stay where it belongs, in your wallet. And if you found this breakdown helpful, make sure to leave a comment below and hit the subscribe button. Because here on Mechanical Wonders, we're committed to helping you understand your vehicle from the inside out. Avoid the most expensive mistakes and get more life out of every part under the hood. Thanks for watching. And stay tuned for more powerful insights that help you drive smarter, safer, and more efficiently.